Pair learning is beneficial in terms of learning outcome, motivation, and social presence. We explored it for symmetric and asymmetric virtual reality and designed, created, and evaluated a co-located virtual reality environment. In the symmetric setup that is shown here, both students are using head-mounted displays. We situated them in the same virtual environment and implemented an application with a learning unit about typical forest animals' characteristics. The virtual forest consisted of 3 clearings, each with a different animal: a deer, a fox, and a boar. Teaching sheets containing the learning unit's information were provided to one participant on a clipboard, who could act therefore as a teacher to the other student. The deer is a mammal and is counted among the cloven-hoofed animals. Cloven-hoofed animals' hooves are split into 2 parts. The deer family includes, for example, red deer, sika deer, and fallow deer. They differ mainly in antlers and hair coloration. It was possible to enable signaling to highlight essential information and guide participants' attention to foster learning. The participants could walk freely inside the virtual environment or use teleportation to travel longer distances. It was further possible to grab objects, such as the teeth of a deer, to examine them. The right teeth are from an older animal. In the symmetric setup, it was possible to hand over objects to the other student. In the asymmetric setup, the teaching student accompanied the other student asymmetrically with a tablet. We implemented a spectator view where teachers could see the environment through the students' eyes. Teachers could not move through the forest by themselves to force them always to spectate the student. The setup and functions of the student remained the same. The teaching sheets could be displayed via a button on the left side of the tablet screen. The nose and ears are the fox's most distinct sensory organs, which it uses to track prey and enemies. We chose a 2x2 between subject design, and we conducted a user study with 46 participants and measured presence, immersion, player experience, motivation, cognitive load, and learning outcome. Our user studies findings show that presence, immersion, and player experience were significantly higher, and cognitive load was significantly lower in the symmetric condition, with moderate and high effect sizes indicating that symmetric systems are preferred for pair learning. These findings matched with our semi-structured interviews, where participants stated that the symmetric system was preferred. Signaling showed significantly higher presence and player experience and better cognitive load for students, as well as tendencies to improve learning outcome. We could further show that symmetric and asymmetric systems can perform equally well regarding learning outcome, indicating that asymmetric systems can be an alternative. We used these findings to define guidelines on how to design co-located virtual reality pair learning applications. Further details are presented in our paper.